Can we measure the built-in potential of an open circuited PN junction diode using voltmeter? The built-in potential is 0.7 volts for a silicon diode and 0.3 volts for a germanium diode. The question is whether can we measure this potential using an externally connected voltmeter to an open circuited PN junction diode. The answer is no. When P and N sides are formed by doping a single silicon crystal with acceptor impurities on one side and donor impurities on the other side, a PN junction is formed at the middle. So this is the junction point of P side and N side. A depletion region is formed in the middle because of recombination of holes which are majority carriers on the P side and electrons which are majority carriers on the N side. Because of this, immobile negative ions are formed near the junction on the P side and immobile positive ions are formed near the junction on N side. To connect voltmeter externally, we must start two terminals from the diode, one from the P side and the other from the N side. So for this PN diode, we have to draw two terminals, two wires protruding from one from the P side and one from the N side, so that we externally can connect a voltmeter to these leads and measure the voltage. The moment you connect these metallic contacts, ohmic contacts externally to this PN diode, now there will be three junctions. One, metal semiconductor junction, because this wire is a metal. This metal we are attaching to this N side. Like second one is PN junction diode. This junction or this depletion region, space charge region, is formed at the time of manufacture only. Third one is another metal semiconductor junction. The sum of the potentials across the junctions 1, 2 and 3 will be 0, and hence voltmeter cannot measure this built-in potential. If you apply KVL, the algebraic sum of potentials develop across this metal semiconductor junction plus PN junction plus another metal semiconductor junction, the sum of all three voltages is 0. So voltmeter, strictly speaking, is trying to measure the sum of all these three potentials, not just the built-in potential, and hence voltmeter shows 0 reading.